So now we'll discuss the theory of zone plate. Okay. So suppose O is the point source of a monochromatic light of wavelength lambda. Okay. So the wavelength of the light is lambda. Okay. Along this line, suppose RPQ, a zone plate is placed. Okay. Then we will observe that at I there will be a bright image. Okay. Now if you again place a screen along I, which is perpendicular to the plane of the paper, then at I we will observe a bright image. We will observe a bright image. Okay. Which will be due to the zone placed along RPQ. So how after placing the zone plate we can observe a bright image at I of the point source. So okay, so now we'll explain that. But first of all, suppose there is no zone plate placed on it. Okay, so what will happen? So O being a point source, spherical beam, spherical wavefronts will travel in this direction. Okay, and then will reach at point I. And we know from Fresnel's and Huygens principle that every point on the wavefront will act like a source of secondary wavelets, and they will interfere, and supposedly they will produce the bright image I over here. Okay. So now suppose RPQ is such an wavefront. Okay. And this is a plane perpendicular to the both of the paper and the line OI. Okay. And our aim is to determine the intensity of light at time. Okay. Due to the wavefront which is emerging from this source O. Okay. So now to do that, what we'll do, we will divide this plane RPQ, which is the wavefront at RPQ, into zones. Okay, various zones. Okay, which are again circular zones with their center being at P. So we have to draw a number of concentric circles. Each of them has their center at P. Okay, and their radii are respectively PM1, PM2, PM3, PM4. In this way, for the nth circle has a radius of PMN. Okay, so we can say that the first circle has the radius PM1. So circle 1 radius is PM1, suppose R1. Then circle 2 radius is PM2, which is equals to R2. Then circle 3, it has a radius PM3, which is equals to R3. In this way, nth circle has a radius of PMN, which is equals to R. Okay. Now these radius are drawn in such that, okay, so we can say that this radii are drawn, or you can say also imagine, because we are imagining a wavefront along RPQ, imagined in such a way that they obey following relations, which is OM1 plus IM1 equals to OP plus IP plus lambda by 2. It means that it is clear that this OM1 plus IM1 must be greater than OP plus IP. Okay, so OP plus IP gives us this much length. Okay, it must be less than OM1 plus MI1, because OM is greater than OP and IM1 is greater than IP. So therefore OM1 and IM1 plus IM1 must be greater than OP plus IP. But how much? Okay, so this PM1 is drawn in such a way, this length is taken in such a way that OM1 plus IM1 is greater than OP plus IP by a length of lambda by 2. Okay, where lambda is the wavelength of the light employed. Okay, so that's why OM1 plus IM1 is greater than OP plus IP by an amount, this lambda by 2. So this is for the the first circle. Similarly, for the second circle, the similar equation will be like this: OM2 plus IM2, it will be again greater than OP plus IP. It will be greater than the so this was for the first circle, 1 into lambda by 2. It will be greater than the second circle by 2 into lambda by 2. Okay, so this is for the second circle. Similarly, for the third circle, we have this equation, relation OM3 plus IM3 equals to OP plus IP, which will be 3 into lambda by 2. So this is for the third circle. Okay, so in this way, if we go up to the nth circle, then it will be OMN plus IMN equals to OP plus IP plus N into lambda by 2. So this is for the nth circle. So you see, by drawing these circles, we have drawn some annular zones on this plane RPQ. Okay, and we see that the path difference from one zone or one circle to another circle is by lambda by 2. Okay, so the path difference from one circle to another circle is lambda by 2. Okay, and between two circles we get an annular zone. Okay, so the path difference from one zone to another zone for I, the image I, it is lambda by 2. Okay, so that's why these annular zones are like half period zones. Okay, for the image I. Okay, so we can write that for the image I, the annular zones which are formed between two circles differ in phase by pi from one zone to another zone, one zone to next zone. So hence these are nothing but the half period zones. So their effect at O will also be just like the half period zone. Okay, so it means that the effect of these annular zones at I will be same as the half period zones as obtained in Fresnel's half period zone theory. Okay, so here instead of O, the point O, we have just have the point I. Okay, so now suppose if we look at the diagram again, you see this OP is equal to U and PI is equal to V. Okay, so now what we will do, we will find the value of OMN and IMN. Okay, so now OP is equal to U and suppose PI equals to V. Okay, so therefore you see from the right angle triangle OPMN, we have OMN square equals to OP square plus PMN square, which is U square plus RN square, which gives us that OMN is U square plus Rn square whole to the power half. Okay, now let us take U common, and we will bring it out of the square root. Then it will be 1 plus Rn square by U square whole to the power half. Okay, now since Rn is much more less than U, so we can expand it using, so Rn by U much more less than 1. So you can expand this square root by infinite series. Okay, so it will be approximately equals to 1 plus Rn square by 2U square. Okay, so which is U plus Rn square by 2U. Similarly, we can show the same for IMN, sorry. Similarly, IMN will be root over OP square, IP square plus PMN square, which is V square plus Rn square whole to the power half, which is again approximately will be V plus Rn square by 2b, because since again V will be much more greater than Rn. Okay, so if we name this equation 1, okay, so suppose this is our equation 1, then now if we put the value of OMN and IMN in this equation 1, okay, so from equation 1 we have, so OMN is U plus Rn square by 2U plus IMN is V plus Rn square by 2b equals to OP is U plus IP is V plus lambda by 2. Sorry, it will be N into lambda by 2.